Okay, in the last section, 7.3, we solved systems by graphing, and that is nobody's favorite. So I'm going to show you a method in this section, 7.4, which is strictly algebraic. You're going to solve without graphing, which is kind of nice. So this first slide shows us an example of when solving by graphing is really not a good idea. Assuming that we are really good graphers and we love to graph, solving by graphing this particular system right here, still not a good idea. Because look where these 2 points intersect. They do not intersect at a nice cross section. They intersect in between. And if all we were looking for is an approximation, somewhere between 3 and 4, somewhere between 0 and -1, then yeah, we might consider solving by graphing. However, if we need an exact answer, then solving by graphing isn't going to work. So we're going to use what's called the substitution method. When we use the substitution method, we substitute one equation into the other, is essentially what we end up doing. So notice I have 7x plus 2y is equal to -12, but my second equation is y equals, all right? So I have these two things are equal to each other. When things are equal to each other, one can replace the other. So what I'm going to do is I'm going to use this to replace my y in my first equation. I'm going to take this, I'm going to substitute it in for y in my first equation. It's going to look like this, 7x. I'm going to replace my y with my -2x. And I'm going to solve this for x. So I have 7x minus 4x is equal to -12. I combine like terms, and I divide by 3. And I get an x of -4. That doesn't mean I'm done. Remember, a solution to a system has to be an ordered pair, and I've just found the x. What I haven't found is the y. So to find the y, anytime you need to find the opposite, if I have the x and you have to find the y, you're going to substitute it into an equation. You can substitute it into the first equation, but to be honest, it would be easier to substitute it into the second equation, and it really doesn't matter which one we use. So we're going to take -4 and substitute it in for x in our second equation. And we get y is equal to 8. So that would be the solution to this system, which, as you can see, is a whole lot easier than solving by graphing. In this particular example, we have x equals, so this time we're going to take and replace our x with 3 minus 2y. So 3 minus 2y plus, okay, and we're going to solve. We have to distribute the 2. We're going to combine like terms. Subtract the 6. And divide by 3. And we get y is equal to -6. Again, we only have the y value. We don't have the x value yet. So we're going to take our y, we're going to substitute it in. Again, it doesn't matter whether we do the top equation or the bottom equation, but I'm going to use the bottom equation. Just because it looks a little bit easier. All right, in general, to solve a system by substitution, first thing you want to do is solve one of the equations for either variable. It doesn't matter which equation, it doesn't matter which variable. However, if you have one equation with a variable term with a coefficient of 1 or -1, that's usually what we use. Substitute into the other equation, solve, find the other value, and then check your answer. All right, so here we have an x with a coefficient of 1, a -4 coefficient, a 2 coefficient, and a -5 coefficient. Of those, this x was the only one that had a coefficient of 1. So what we're going to do is we're going to take the top equation and solve for x, and then substitute it into our second equation. So we are going to solve for x, and then we are going to substitute. Make sure you substitute into the other equation. Don't substitute it into the first one. It happens. And distribute. Combine like terms. Get the y by itself. And divide. All right, we just found the y. We still have to get the x, okay? So we're going to take this y and we're going to substitute it either into the first equation or the second equation. It doesn't matter which. It's looking like this first equation is going to be a little bit simpler. Generally, what I'm looking for is smaller numbers and or positive numbers. Okay, so smaller numbers here, that's the one that I'm going to plug it into. So I have x plus 1 is equal to -4, and replace that with my y value. And subtract 1, and I get 3. All right, remember in 7.3 where we talked about the special cases where we could intersect at a point, we could have two parallel lines, or we could have the exact same line. So we had case 1, case 2, case 3. Okay, and we figured out, you know, how to determine which of those cases we had when we were graphing. But what happens if we're solving by substitution? Okay, so it could happen. All right, we could have any of those three cases when we're solving by substitution. So you guys need to know what that looks like. So we're going to solve by substitution. We are going to take this and we're going to substitute in for y. We already have y solved for, so 16x, 8x plus 4, distribute. Combine like terms. Notice. My x's canceled out, and I don't have any y's. No y's, no x's, no x's, no y's. When that happens, when both variables are eliminated, then we have one of those special cases, okay? So how do you know if it is no solution where they're parallel, or if it's infinitely many solutions where it's the same line? Well, you check to see if the numbers are equal to each other. If they are equal to each other, that's when we have infinitely many solutions. If they're not equal to each other, that's when we have no solution. In this case, -8 is not equal to 8. So this is a case of being parallel. no solution. And don't forget, the empty set is a symbol for no solution. All right, let's see. This one, we've got an x with a coefficient of 1, but this is 3, 4, and 12. So it looks like we're going to solve the first equation for x by subtracting 3y. And we're going to substitute into our other equation. And distribute. And combine like terms. And notice once again, my variables canceled out. They're completely gone. And I'm left with two numbers. One number is equal to another number. And in fact, they are equal to each other. So this is the case where it ends up being the same line, infinitely many solutions, which again, in set notation, just pick one of the equations, x plus 3y, like that. All right, I'm going to pick this up in another video. So I'm going to stop this video and I'll see you in a bit.